All right, welcome back. How's it going? So I was tweaking this falling plaster statue guy or whatever. We were doing the grain simulation. I still want to try to get it looking a little bit better. It's like a little too crumbly right now or something. Just like too fuzzy in certain areas like that. So I want to get just some more detail, more of these chunks to be more rigid and stuff like that. Alex, yes, I'm tired too. I don't know what's going on. I woke up like super early, had trouble going back to sleep and all that. But it's late for you, right? It's late in the day for you. So certain stuff like this is pretty cool to see these stripes or like striations or whatever. But yeah, I'm probably just gonna keep tweaking this. Right now this is 20 million points, and like I was saying, I switched the stuff over to vellum. It still uses the same attributes: attraction weight, attraction stiffness, to manipulate the solving, so you don't need to rewire like the other stuff basically. So just took this chain, moved it over, and was doing other tweaks and stuff like that as well. But I'm gonna put this scene away for right now. Close this Houdini out. I think it was like slowing my computer down with the redshift or something like that. Just try kill all the Houdinis. Do it now. All right, I got it. Yeah, so I was working right here on updating. I don't know if this is a little too small. Updating some of the attribute spreadsheet or whatever cheat sheet that I made. So, Sir Shades of Orange, he did a nice thing for me, sharing the link on my website. It was this attribute rundown or whatever. I brought it up on the stream before, but it's just this kind of consolidated glossary of attributes that you can use for different areas of Houdini. So I'm working on adding it for agents, like for crowd support, vellum, maybe tops USD, the loops, like for each loops you have some iterations and certain attributes like that, packed and other stuff. It's 2200 for you. That's pretty late. It's not ideal. This is probably the best time for people, I don't know, like London or France is probably like 5 p.m. or something right now. But they're all in the streets. They're making noise. So we'll just get a new Houdini open. And I was finished up that glass stuff that I was working on yesterday. I showed that one still or whatever. So on my Instagram I put up one more image to kind of complete this set of 3 things or whatever, and then I had some extras that I tucked in, just like super tight close-up shots of the caustics or details or stuff like that. Doing some depth of field and all of that. So it's then this tinted kind of colored glass ombre or whatever is pretty interesting, pretty cool to set up with redshift. So I was just doing that with like a point attribute on the geometry and then using that to drive transparency and stuff like that. London is 1 hour later, so it's 2300 there. Maybe I don't know, maybe I need to adjust my stream time. This is like the ideal stream time for the Azores, maybe. You guys see where that is on the map? they're like right in the middle of of the ocean. They're the only ones that this is a good time zone for. I don't know what oh, they're 21. I don't know what they're. It's 8 p.m. so it's a good time if you're in the Azores Islands. All right, so let me just get everything situated here. So yeah, this is just going to be more R&D kind of stuff. I had some different ideas with Pyro things, advection and that type of stuff that I wanted to play around with. So we'll just get started with that. So I'm just going to go in and kind of set up a simple Pyro simulation. So I'm just going to set this up like I usually do. This box is going to be the domain size. You just do this ends just to unroll. This just makes it like a wireframe or opens up the faces. Now I guess we'll just stay with using the particles. I don't know, maybe. Yeah, sometimes I like to use these shapes. It's just kind of like a interesting starting point or whatever. So I'll make this domain a little bit bigger. That should be pretty good. Gonna switch this to delete geometry peak points. Then we'll make the p-scale attribute. We'll just make that like 0.01 or something like that. We could visualize it like I usually do with just the disks. Maybe that's a little bit, whoa, it's a little bit small. Go up to 0.075. Whoops. All right. So I think we're good with all of that stuff. So let's go in here. We'll make our smoke solver. Smoke object, just to get this guy going. Then we'll just do our expressions. So we want the B-box size. One of the things you can do instead of, I think it will work. So instead of, let me see. Instead of specifying the node path, if you want, so like a small shortcut, like usually I do ... like that. You can do -1. And what this does is it uses something in Houdini called spare inputs. So if I do -1, and then I want the index number 3, and then the part of the bounding box I want to know about is the d_x size. And then I don't think I need these backticks that I was doing. So at first it doesn't know what -1 is, but that's referring to the first spare parameter that you create. And then those just come in at the bottom. So I think here if I just do, maybe it won't work for me right now. Maybe I have to do that .. One more dot. Alright, maybe it's not going to work for me. I shouldn't have tried it. So you could just do delete all spare parameters, and that will clear up that garbage. The other thing you can do, sometimes I've used this before where you just set these up once and then you do save as permanent defaults. But just with streaming and working at other places and stuff like that, I don't really like to rely on too many presets like that, just because other people won't, it makes it harder to kind of follow along or whatever. So we'll do centroid, and then this one we just do 0, 1, and 2. We're good to go. Solve on creation. I think my division size I can get away with starting a little bit smaller, and do multiple solver with a SOP solver. So this guy, we're just going to get the input index 0, the first input. So now we can see our geometry. We can do particle to field to source these directly into our volume. So we're going from geometry, which we've just sourced or imported into the dynamics network. Destination field, might want to start with density. We don't need to use attribute right now. Don't want extrapolated. Threshold, I usually go down to these lower numbers, something very close to 0. So that just makes it like a, instead of a blurry kind of source, like it's a constant value over the entire radius of the particle. And then instead of copy, you just want to do add, so that it doesn't replace the existing density field. So we're good. Maybe we could go down a little bit lower, and let's do the OpenCL. And then just to finish things up down here, usually just do density, and then to display it, convert to VDB. So this is usually my default way of getting volumes in from just setting up like a simple solver and all of that stuff. And then if I want to change the density or whatever. So we're adding them in, and then as well I just turn off caching. So if we look at it, now it's playing back close to real time or something like that. So and then pin the view and add a light, and then we're good to go. So these lights, if you don't have a light, you'll basically just be using the headlight, or your light will always be in the same position as the camera, and you won't get shadows or stuff like that. So we don't have any motion. One thing we can do, I'm just gonna double up on this particle to field. So we'll do temperature as well. And now we have some buoyancy, some thermal buoyancy. The hot gas, the hot fluid rises up into a slow cooling rate, so it doesn't get too blurry. That kind of should preserve some of that detail a little bit. I'm sorry, that's actually the temperature diffusion. So that would hopefully preserve some detail, some sharpness in the buoyancy motion. Maybe we do want this cooling rate just reduces the heat over time, the temperature. And then I'm just gonna do turbulence. And this guy we want to grab as well the OpenCL parameter. So we'll link it up. And I think most of our settings are good. Control settings, maybe temperature. So the buoyancy is kind of driving this turbulence as well. then just kind of jacking these. It's not attached. It's a good way to check sometimes. You just set these values to super high things, and if you still don't see a change, you know you did something wrong or something's broken essentially. So it's working now. Let's go back down a little bit lower. It's looking somewhat interesting. I'm not super concerned with what's happening here too much. I'm just trying to get some like interesting motion set up a little bit. The other thing I might do is like, this is kind of a hack, but sometimes I use it as this gas intermittent solve. And then if you have it set only once, you can do some interesting things with this. So that Black Cuckoo, how's it going? So this this actually isn't doing what I want. Maybe I can do it down here. Okay, yeah. So what that does is basically say just run all of the inputs, all of those operations one time. You can also do other things like this. We'll just do once per frame. So if you have substeps happening underneath, it won't everything above it won't happen like every substep. It will just happen once per frame. So you can do interesting things with this, but sometimes I use it just to have it like set up my source. It's the same thing as doing the $SF == 1 on the activation or whatever. But it's good. So just gonna tweak these settings a little bit more. Just trying to get some interesting behavior kind of moving around right now. And then I usually switch my advections up a little bit to go to the BFECC and the trace RK3. So sometimes those higher order advection models and stuff can preserve some sharpness or detail kind of in the smoke. Now I might I just scattered more points on that to kind of turn it into like a solid object, just to kind of create more smoke, fill in the gaps a little bit. All right, so we're getting some interesting motion, stuff like that happening. I'm gonna go in here and then do closed boundaries with my domain or my container. So what that does is it won't allow air or velocity. Why am I not seeing any? Okay. It won't allow velocities to move past these barriers. Like without that, stuff can freely flow in and out of the domain. But now everything's trapped, or it will treat this like solid ground planes or collision objects. So instead of having this stuff swim or streak right through it, it will just roll up against it and all that stuff. You get like a smoke filling a room or smoke filling a box or something like that. It's pretty cool. Then I'm gonna stop with that simulation for a little bit. I'm gonna do another thing with this box. So I might just do subdivide. I'm gonna create like some little streamers or lines or stuff like that. So each of these points, I'm going to copy a shape onto it. Just do, not the old one, but just copy 2 points. We'll copy lines onto them. And then right now they're pointing kind of the wrong way, like they're going along the surface. So if we switch this direction to Z, Z is like the local up vector for these points. I think maybe with this facet, if I do unique points like that, that just like on the edges, instead of these points being shared, unique means to separate them out into 2 different directions, so it's no longer like the average direction pretty much. So we got our streamers. I'm actually going to do this facet 1 step earlier, and then the reason to do that is because I want to shrink stuff before I subdivide it. So another hack with this primitive, you can do the scale parameter. So if these weren't unique or separate faces, I wouldn't be able to scale them down individually like that. So now I have my streamers and they're all pointing, they're no longer like any that are right on the edge. Then I just want them pointing the other way, pointing inwards. We'll just do negative direction. We're good to go. And then I think we're ready for the next step. So I'm going to get the velocity field from Mr. Dop Network. It looks like my drag, it's just a slow drag and drop or something. Into this object. Just need to say, so colon is saying like get something from the DOP network. It's a special syntax for DOP networks especially. Usually use slashes like just to go into different directories or different containers within Houdini. This colon is like saying retrieve something from a simulation. And star is saying any object. So if I look at this spreadsheet right here, we just have the smoke object, but I could have other things like ground planes or RBDs or stuff like that. It's just a lazy way, so I don't have to type the smoke object. And then a slash. So the slash is saying from within the smoke object, we have different options. We have all these different fields, temperature, burn. Could even do the geometry. If I wanted to like pull the particles, the source particles back out, I could do that. So we just do geometry. Then this guy is just pulling the source particles right back out. But instead of that, I'm interested in the velocity. So we just do vel. Then we have our velocity field, the 3 different volumes for each direction. We're gonna convert that into a VDB as well. And then usually you do vector merge with VDBs. It doesn't like the velocities or 3 components split into different volumes. Like it wants them all in this vector 3 smoke or volume. And then usually I just change that. So we have velocity information. We advance to a certain frame. You can do slice to sample those values onto a grid. You can also do the trail. This is like the common way to visualize things. So now these are getting kind of pushed through the velocity field to show what direction everything's heading in. These things can get a little bit weird, like there's no values. There's very small values, so they're all going a unit length along these directions. So instead of doing that, if you do advect by time, then this is a little bit more, it's a different method, but this is basically saying take one time step through the velocity field, where the other one was saying like all these streamers go 1 unit of space through the velocity. So we'll do a solver. And then in the first input, I'm going to bring in these lines. And in the second input, the velocity. We'll do advect points. Usually I add some substeps just to have more precision, and then I match up that advection integration. So I'll reset this to the first frame. Play the simulation. It gets a little bit slower because we're retrieving the velocity field each frame. So I'm just going to go up in division size. And then the other thing is that these lines are only constructed of 2 points, the start and end point. So it's not a ton of resolution, or it's not a ton of like topology or information for the pyro to push around. So instead of like blowing little streamers, it's treating these all like super big twigs. It could be cool if you're doing like a data storm, or just like rigid transformations or whatever. We could do resample just to add some more resolution. So now these guys get kind of wiggly, pretty cool like that. But you can see we have a problem where they get stretched or pulled too far, and then it just kind of turns into a mess because we have just artifacts from streaks or stuff like that. So just the things get pulled too far and they lose their fidelity or their detail. One thing we can do to fix that is just do another resample, but I'm going to copy and paste it inside of the DOP network. So if we put it right here, anything from the previous frame will be resampled and then advected along the velocity, or moved by the velocity of the pyro simulation. So it's a little bit, can get out of control pretty easily because you're resampling, or you're creating or modifying the topology every single time step or every frame. But for certain simulations or certain results, it's like the only way to get what you're after. So to preserve this amount of detail or resolution or whatever, this is the only way to do it, with kind of resampling or upresing, or just making sure that the points are spaced out along a certain like tolerance every single frame. Maybe do a little less subdivisions, just to see what's going on a little bit easier. Could be cool as well. Maybe we just keep a specific, only just one face, like maybe the ground, just the bottom of it. See what happens. It's pretty cool. You get like some interesting wispy line style smoke and stuff like that. I'm just gonna keep going and trying out some other stuff. So maybe we'll play around with a sphere. And then just apply the same process to the sphere. But you can see now this resample doesn't work as well. Like, it disconnects these edges so they aren't attached. So instead of doing resample, we can do remesh. This is a similar thing, but it will just make sure to keep those edges attached or welded together. So it's pretty cool, but you can see there's some problems of like things doubling up on each other, like overlapping. I'm gonna try maybe starting with a smaller sphere, and then with this resample, the smaller edge length. So there's some stuff here that turn into lines or kind of problems like that. Oh no. It's kind of cool, but it's not, unfortunately, it's not that easy to control. Yeah, that would look cool if we have some colliders or other stuff like that happening within the DOP network. There's like an invisible kind of collision, or you could reveal a shape that way or something like that. Yeah, that might be fun to try. I'm just gonna continue with this. You want to peek inside the solver? So all of these is just doing idvect points, which is just moving the geometry by the velocity field. And then with the first example with these lines, I was just resampling them every frame. So just keeping the points spaced out along a certain constraint. And then this one is just replacing the resample with remesh. It's a good peek. Sometimes I wish that Houdini was laid out like Katana, like that graph. You guys ever used it? It's like lighting software, like specially used or whatever. But they basically don't have a they don't have different contexts. Oh, the peak sop. Yes, that's a good idea. I thought. Sorry. So with Katana, I like it because you can like expand kind of subnetworks or whatever. So you're not like diving in and out of nodes as much as you're always kind of working at a flat level. I don't know. Sometimes I wish Houdini was laid out kind of like that. Yeah, so we could give this a try. So do a peek. So I don't know how much we want to do. If we do too much, we might get like a runaway inflating balloon effect. This is looking pretty good. So sometimes I'll do this clip just to kind of debug the geometry. So that, like you could see, we're kind of getting some issues here, like if you cut into a head of lettuce or something like that, or cabbage, like you see all the little other leaves and stuff all packed and squished inside of it. So that's kind of what's happening here. So even though this doesn't look like a ton of geometry, where it's a lot more than you would think or whatever, because there's a lot of folds and stuff happening inside of it. So it's, you could get some interesting things, especially if you did like the transparency or whatever. We'll just make alpha for the viewport. You could get some interesting effects, like seeing it get wrapped up inside of it, but for right now it's gonna slow things down a little bit, so I might gonna keep going. So the way I think we can get around this is maybe doing VDB from polygons, and then get something a little bit higher resolution. And then instead of doing all of this stuff, I think I can just do VDB at vect. This level set is basically what this data type is signed distance field or level set. So it's similar ideas. We'll give this a try. Is it working? It's kind of slower. So you might get some holes or issues like that. These might be related to the substeps again. We'll go. This operation is a little bit more expensive than points, so we might want to be a little bit careful with it. You can do a similar thing as the peak SOP, but with reshape SDF. So you do like a dilate, and that will push things out or kind of inflate stuff every time step. I'm gonna hold off on that for right now though. So I'm gonna go into my main, my main DOP network, working at a little bit of a higher resolution. Keep bumping into that flag. So we'll just do a flipbook with it at this at that slightly higher resolution with the advanced something's happening. Maybe I need to check that on. So it's just a slightly higher resolution velocity field and more substeps and stuff like that that our advection is taking into. So we'll just let this run for a little bit and see what happens. Still collapsing. So I'll just let it go for a little bit more. I'll go get some water. I'll be right back. It evaporated. Poof. This could be cool for something, but it's not ideal for what we're doing. do I think the VDB effect is trying to keep the SDF volume area the same throughout? I don't think so. The pyro solver is kind of, or the smoke solver is kind of trying to do that with like the pressure projection, the non-divergent phase or whatever, but this, it doesn't take any of that stuff into account. So I'm just gonna leave this dilating one voxel. I might do a smooth as well. So this one will do like a slight blur, because I think those two should kind of balance. Hopefully they'll balance each other out. The dilate, everything will keep expanding a little bit, but the smooth kind of peels it back or strips it away a little bit. So we could check, kind of do a side by side right now. So if I just look at this, got a runaway solver. It doesn't want to stop. All right, I think we're good. So if I just pull in the smoke, we can see we're getting a pretty close match now, which is pretty cool. It's like almost 1-to-1, or we're doing a better job representing it. We're no longer like completely dissolving in on itself or whatever. And then because this is in SDF, it does a better job at keeping track of inside and outside. So like, what I mean by that is just the way that this represents things. If we turn off visualization, I'm gonna turn off lighting, and then I'm gonna turn off the back facing tint. What this does is any value inside of it uses negative numbers, and any value that's positive uses positive numbers. Any value that's higher or outside is a positive number. So this is able to keep better track of that information, and then it avoids the folding in on itself that we were getting with the remesh based on polygons. So we could just go convert VDB, polygon soup. Maybe we want to do another layer of smoothing right here, just to get rid of some of those. Sometimes with the SDF, or because it is a volume, you do get like some ringing or just stair-stepping kind of artifacts like that. We could do another kind of iteration of smoothing. Just gonna go back to the headlight for now. And let's let this just do a flipbook and see what happens. So we fixed that. We might have one issue where it's like constantly going to be growing, but this is kind of why we're doing it, as like a growth effect. If we wanted just a volumetric or surface representation of the smoke, it would be better to just convert that density field from a smoke or float fog volume to distance field and then do polygons. But I think we can get something kind of abstract or interesting or whatever with trying things this way. So it might be maybe a little bit slow to run. It's possible that it's either my like velocity field of the smoke simulation is a little bit too high resolution, or maybe my SDF, my volume here is a little bit high of a resolution. But you can get some kind of like that differential growth or whatever. This was like pretty popular a year or two ago or something. People were doing this kind of stuff with so people were doing it just all inside of a SOP solver without doing I think they usually were doing VDBs, but instead of doing the smoke solver like pressure projection, they were just doing this based off of noise or curvature, and then moving or advecting the surface based on that. You get some cool kind of abstract things. And this looks like it's more closer to what we were doing earlier with the wires, with the lines. Moving them, looks like it's definitely a smoke pyro simulation. You see the pressure fronts, the mushrooms. It's pretty cool results he got with those. It's pretty cool. It doesn't look like it's getting any more interesting, so I'm going to stop that simulation where it is. We'll try Alex's idea from earlier. So we'll do, we'll get a collision inside of our DOF network. I'm just going to do a Taurus, maybe smooth it out. And maybe play around with this radius so it's a little bit thinner. And then do VDB from Polygons. So the pyro solver, the static objects usually like to operate on VDBs. So if I go in here now, just do static object. Get him in there. And we can ignore all of this stuff. But for the volume, we'll just do volume sample, and for proxy volume, just do you get middle mouse button just to make sure. Then because I have my view pinned, we don't see it right away. So I think if I might just be an issue of like first frame or not. Oh, so I just don't have collision. Geometry enabled. I think if I wanted to, I could copy this and paste it. Whoops. Up there. just as a visualization, but I don't know, it doesn't use that. This one is usually looking for polygons, so it might, I don't know. We'll just play this and see what happens. So it definitely looks like it's flowing around that Taurus, the donut, getting some cool motion happening. We could try maybe our lines are starting on the surface of the donut. Could be cool. Let's go a little bit shorter with these things, and then I think instead of being inside, we want them pointing the other way. Maybe we don't need as many. Just scatter. So when we scatter, we lose the normal like surface direction information. We can just add it back or record it with the normal before we scatter. Maybe just trying to get some less points overall. Let's see what happens with this. We'll just do another flipbook. So it looks kind of interesting, but it's a little hard to tell what's going on, and some of these might be. Sometimes the solver can have like mistakes, and things can get allowed to fold through stuff. So sometimes that can be an issue. What I might, let's see what happens. I'm just gonna try something. So I'll do another peek, but with the Taurus. It's worth a try. No, I think it's a good idea. I don't think I set it up 100% properly. So I'm gonna try something. I'm gonna keep going with it. So I'm doing a peek with this Taurus, and then I'm gonna use that to supply my scatter, basically what will be the volume source. But it blows up. It disappears. So what I'm trying to do is make smoke inside of the Taurus. But right now it's thinking that the Taurus is the collision object, and everything outside of the container is empty space or empty air, like empty volume. So if I just click here, you can do this invert sign, and you can't really see visually what it's doing, but it's basically switching that relationship. So now all this exterior, maybe if I do, that doesn't change anything either. But it's basically flipping this around. So just the interior of this Taurus will be air. So it no longer deletes it on the first frame. Now you can have stuff blowing around. So it might be even easier to see. We'll just do like 2 points. If we are going to do things this way, it might make sense to optimize our container, because we aren't simulating all this other area. We don't need to. We're already doing like basically a closed container, if that makes sense. So I think we could do 1, 3, maybe. It's pretty good. So now things are faster. We could push like a higher resolution or something like that if we wanted to as well. Let's go up more points. I'm also just going to press the D key, turn off my limit resolution for 3D textures. The 3D textures are volumes, just another name for them basically. And because we optimized that container a little bit, we could go up in our resolution. So our simulation isn't that high of a resolution still, but it's just a little bit better or sharper or whatever. We get some interesting motion with like, because the velocity field as well is constrained to be within this torus. You get some interesting like circular flows or stuff like that. Pretty cool. And then basically this stuff is going to slowly stop moving, and that's happening because the temperature field cools down, which is what's driving that turbulence, and also the buoyancy. So as time progresses, our gas cools, which is linked to all of our forces. So everything kind of slows down over time. Let's try more of these, and maybe have them be smaller. So let's just see what happens with our lines now. We just need to flip them back around. So it could work pretty well. Sometimes I do this wireframe node here just to like do a thickness visualization. You can also visualize with thickness or whatever if you just do this shade open curves, and then you need to add a width attribute to control that. One thing I'm a little bit worried about is that maybe even in this solving process, like it's not factoring in collisions. So some of these guys I think are falling or getting pushed outside of the torus. They're escaping and then they're just sitting around because there's nothing else to move them or whatever. So that not only causes issues because you see like little hairy artifacts or whatever, but it's also going to cause streaking because like as soon as one of these gets caught in an empty no velocity area, the rest of it, the line will get pulled, so it's just additional like messiness or stretching or whatever. So we'll try to fix that issue. Maybe just to be a little bit clearer, if I just template flag this on, you can see we have some guys here that are they got left behind, they got stuck outside. So you do group node, you can use this other input. I don't want the base group. It's like if you're using an expression or something to say like these include these points. I want my group to be a point group type, and then instead of bounding box, we can use this. These ones use the auxiliary or the extra input. So I can do bounding object. And then if I switch, so if you just switch it into this gizmo over here, the transform handle, then that will highlight what is a member of the group and what isn't. So we can see this group, we can just rename it now to inside. And then what we want to do with these with these points or with that group, I'm just going to do a null to keep things a little bit more clear. This would be collision. We could use the ray node. Instead of project, we could do minimum distance. So this will snap everything to the surface. Instead of doing that with everything, we want to use that inside group. But that we want to flip it around. So we just do exclamation point. That will say everything except what is inside of the Taurus. And then use this lift. You kind of see what it's doing. You can also use the scale, I think. These guys will do different things. I'm just going to do another peek to be a little bit more sure as to what's going on. So instead of snapping to the actual surface, we'll just peek the surface inwards a little bit. I don't want these guys to move exactly, to get pushed exactly onto the surface. I just want them to be lying barely inside. And I think I might need to, yeah, so that's a little bit of a gotcha, is that group type, you just have to be sure it knows which one you're talking about. So instead of doing this after the simulation, we can move all of this and just shove it inside of the stop solver. Just do Control X to cut it. We'll use one of these extra inputs, link it up to the subdivided torus, and then just plop them right in. We'll do another flipbook, see what happens. Stuff should be hopefully a little bit more organized, so we don't see as much streaking or stretching. It's nice to see some of it, but it just gets a little bit too busy, I think, sometimes, or it's just too, it's a good thing to be able to solve that issue as well from a technical standpoint. So I'll let this simulate out. I'll be right back. This is pretty cool. It's like properly getting filled somewhat. So I think it's going to be a little bit cooler. Let's start with these lines super small, like such that you don't even really realize that they're there. I'm just gonna set this up properly to visualize, because that way of visualizing stuff can get expensive when you have a lot of lines. So I'll just make a width attribute and then turn it on up here. So what that does is it's just going to draw these lines with some thickness. I think you can change the way that they're drawn with this polyframe, possibly. If you set different things to the normal, might be orient. Maybe it won't let me do it right now. I'll ignore that for right now. It's possible that they are just constrained to always look. They're always facing the camera. I don't know. I'm not gonna worry about it too much right now. So we'll put these guys back to be really small. Daul, thank you. Good to hear you think it looks nice. It was Alex's idea. He gets all the credit. So maybe this turbulence, just crank it up a little bit to be like a little bit more of a boost. Like it's like a washing machine. Making a washing machine commercial here. Spin dryer. Pasta maker. I don't know, it's cool to do this kind of collaborative R&D. So it's pretty cool to see them lingering around like that. But let's do one more thing. Maybe make them even smaller. I'm gonna reduce this kind of like a bias, I guess, because that was constraining them to be, that was what was making them a little bit more visible as well, because immediately it was seeing them too close to the exterior of the shape and pushing them inwards. Let's increase this. You have to be careful with this length, because it's like, because it's happening every frame, you can get out of hand and crash your computer, fill up your memory kind of easily with it. We could go up res. Just do a scale of 10. So this is still a pretty workable resolution. We'll just save this, make sure we don't lose any valuable progress. Is this the 14th? Oops, you gotta do the month. Yeah, I don't know. I mean, this is it's nice that you listen to the ideas. This is what kind of why I was interested in Twitch. I guess you could do the same with YouTube, like streaming or YouTube live, but it just seems like Twitch has a better kind of community, and I like their emotes more. So we saved it. Now we'll just do a proper flipbook with higher resolution settings and stuff like that. Yeah, so I don't know, I might do some of the more technical stuff that I was getting into yesterday or that I've done in the past. I might try to just do proper like recordings of those, like offline recordings, and then put them on YouTube or something just to try to build like a bigger community or audience. But I like doing these live sessions and stuff like that on Twitch. I think there's a good potential for future having fun and getting more people in here and stuff. So this might be too slow to operate. We'll see what happens. It's possible. It's possible that I don't know. I was trying to think of a way to constrain these roots or like the starting points. So because it looks like the whole line is getting pulled a little bit, but we might want to stop that from happening so that like the root points of the original curves are always stuck to the surface. If that makes sense. We might look into that. We might also just have to dial back these settings a little bit. So if you look at this, it's probably too small for you to read, but this is like telling me what's taking the most time, what current operation is cooking inside of Houdini. It looks like it is just fetching the velocity field from the simulation. It gets to be pretty expensive. All right. This is not even looking better, so stop wasting time with that. So we'll go back up here, just do 0.012. So this one, I think I can get it. Might be I think one of the issues is that these lines are now too short, such that they're moving around, but they're being treated as they're like a single point, so they're no longer, very few of them are growing. So let's just do a simple proof of concept over here. I'm gonna get into some vex. It's just gonna be easier to lay things out. Explain it this way. So we have a bunch of lines. We want them going up. And then we want more points. And then what I want to do with this wrangle code is to be able to find the root point or the bottom point of each of these. But if I do it with attributes, I'm not sure if those will be saved each time, like if I'm resampling stuff. So I want a way to do it using just like kind of implicit the nature of the lines or whatever, like without attributes basically. So there's indexing variables, indexing attributes inside of Vex. If I go back to my cheat sheet from the website, you can kind of see we have some here. So that we have the current point position. That's what I mean is like implicit is that this doesn't need to be stored. Like this will always exist regardless of what's going on. The same thing with all of these other ones. These aren't actually like existing on the geometry, but it's kind of things that the code that Vex understands whenever it's operating on any geometry, basically. So I think You can do stuff based off of this vertex number. So if we look at, just set this to the color. It's my lazy way of always visualizing things. It's a little bit hard to see what's going on, so maybe I'm just gonna say if it's equal to 1 or equal to 0. So it looks like it's never equal to 0. I'm just gonna pop this guy up here. So it looks like we do have 1 point. One of them is evaluating true for this condition. I think we can do the modulo, and this divides, but we're just looking at the remainder of num VTX, num vertices. So I think what this is doing is getting the point, like, number but per line. So if I do put that in parentheses and then check if that's equal to 0, now you can see each line has its little white dot. So with these, we don't need that. What this is doing is basically scaling all of the vertices, vertex numbers, and then modulating it or just dividing it by the number of vertexes per curve. You can also look over here if you go to vertex mode, and there's a difference between like linear vertex number and all of that stuff. It can get carried away quickly or whatever. This is basically our quick way to find the root point or the starting point of the curve. Each curve, even different curves, like I could plug 50 curves or 20 curves or whatever, and it will always find all of the root points of every curve. And then this is our condition, just to say if it's true or not. So I can just copy this code here, copy the entire wrangle, and just do it at the end here. Do it with the collision. So instead of making the point white, what I can do is just do an if statement. So this is a condition. It will be true just for the root point like we visualized. Hey Julian, how's it going? We're a little lost in the sauce right now, but we've been doing this kind of RnD, moving curves around with pyro velocity fields and stuff like that. So I'm just trying to write some code right here to constrain the root, the endpoints or the start points of these curves to their original constrained position. So I have code right here at the top that's basically saying if it's the start point or the first point of the curve, the root. This is a quick way to do kind of what the Resop is doing. We're just gonna rewrite it in Vex or whatever instead of doing another. You could do another group and then another Resop, but I'm just gonna do it this way. So we get this is going to be primitive number and primitive UV with parametric UV coordinate. Then you can do XYZ dist. 1, so we'll do this auxiliary input from, I want the XYZ dist from the current position of the root point. And then I want it to tell me the primitive number and position on that primitive of the nearest position on the surface. And then I can just set the point equal to that parametric position. So prim UV is just saying get me the surface position of this input. Mess that up. should just be the position attribute of this input on whatever primitive number and primitive position that it finds. So you should be good. We'll just do another play blast and do a proof of concept. Is it working? I don't know. Thank you, RH2. We're doing a pasta maker. It looks like some of them aren't sticking. All right, let me just try making a rest position up here. Then instead of doing all of this silliness, I'm just gonna set the P directly to be rest. Maybe we'll do that vector just to be certain. I'm also just gonna pull a little bit back on this length just to be safe. And then I did turn on the interpolation to be subdivision curves. So if it does resample things, that should be a little bit smoother in terms of, like, you have a line that's just kinked out like that, the subdivision will interpolate kind of like a Bezier curve or more smoothly. So it looks like this rest position stuff might be working better. I think my prim UV stuff, that was actually letting things get like scraped along the surface, whereas using this rest position and then snapping it back to that will be more of a forceful constraint. But we do have some other issues. All right, stop that for right now. So I'm gonna, I have a feeling maybe when I'm resampling, like these curves might be getting flipped around from frame to frame because the topology is always changing like that. So instead of doing all of that, I'm just going to maybe try it by an attribute. So we'll do if the X component or the red component of the color is greater than 0.5, do my constrain to rest position procedure. And then I'm just going to grab this one, and additionally to rest with this condition, we'll set the color to 1. So this guy is going to set the color to the root points, and then based off of that color, this guy is going to anchor the points in. Might be running into some issues with that. The resample node, it might be like interpolating the color, smoothing it out. Let me try increasing this so that it has to be above 0.95. If this doesn't work, I might just give up. I think I also might have made another mistake. So I should be renaming or removing the color afterwards, because if it is working, I'm not even gonna see what's happening. So I'm gonna delete color. It looks like that wasn't the issue. So maybe I don't want them so small at the start. Let me see what happens with that. Nothing. Is this one not even finding? I'm gonna give up on this right now. We're just gonna set that stuff aside. I think we can get a little bit shorter with that stuff. See what happens. We had some really good results, and then I got I got finicky. So I think we're causing issues because they're too short at the start. One thing you could do is like a post-process, just to say if the lines aren't, like they don't meet a threshold of a certain length, scale them down after the simulation. That might be a better approach than trying to fix everything in simulation like I'm doing here. It's usually a good idea to fix as much stuff as you can in the simulation, but sometimes you have to add some hacks and stuff like that on top. You guys saw my cartoon? This is like the kid that's he always has this progress bar up on his Houdini. His dad comes in to check on him. He's 2-3 hours deep in a simulation, saving geometry out or whatever. So this is pretty cool. Getting these, we're starting to get some folding and differentiation or whatever up there. I should have done it properly with the actual, I was like replacing this to say, are you simming? Are you winning, son? I feel like that meme is outdated, because like all the younger kids, their dads are all probably gamers. They're playing like Warzone or all of those games, even like some kids' dads are probably playing Fortnite. That game is already like a generation old. So this stuff here is pretty cool to see some of like the billowiness and stuff like that. What I'm going to do, I'm just gonna color these primitives at the start. The times are changing. We'll do bounding box, but I want these to be primitive colors. Yeah, I don't know what's happening with the... I just need to reboot my computer, I think. I don't know. I don't know if I was pushing Redshift too hard and it just like borked something. But yeah, I think that chat might be like a 10-minute delay, or have to sort it out. Press type 1 in the chat when you hear this. We'll see how big the delay is. Oof. This is pretty bad. It's like at least 10 seconds. So I don't know how we got some gray. Or no, those are just frames that are new frames or whatever. Yeah, so this is going to be pretty cool, I think. Looks like Alex has the most delay, or he's just not typing it in. It's like we reverted back to actual dial-up internet speeds or something like that. So I don't know, the amount of curves that we have right here is feeling pretty good. It's fancy. Yeah, it turned out to be, this is all thanks to Alex. It was his idea to do like, I was just blowing curves around and his idea was to put it inside of a geometry, so it's pretty cool. I think everything is working pretty well. I might try some different distributions of streamers, of lines. So right now, we're just basing it off of the Taurus from the collision. I'm just gonna make a reference link of that, because I want the size and radius and everything to always be locked in at what it is, but I want to override just the divisions. So the actual shape the scale should match up, but now we can override or change the amount of streamers we're making. So we'll do maybe these like little triangles. Looks pretty cool. I'm just gonna save another version before I get carried away too much. Sometimes you like change turbulences and other things like that, and you ruin the look and you forget what your settings were at. So maybe even try like, whoops. Yeah, so we'll do swirl size a little bit smaller and scale a little bit bigger. And I'm just gonna make one more division so that we're symmetrical. And I'm gonna try decreasing this again to get some more resolution. Could be cool with these things even thicker. We've been seeing a lot of people doing, you've been seeing them on Instagram, those materials. The one guy's name is, it's like Vincent, not sure how to pronounce his last name. Schwank. He makes these really nice like cloth fabric shaders. He did some streamer type stuff somewhere. Kind of like these maybe. So if you had these, I think I messed it up with my settings. It's too much turbulence. But if I don't know, this is kind of like silly string. You guys ever have that stuff growing up? This it's kind of like this goop. It always gets like melts onto you and stuff like that. Silly string only vellum. Oh, sorry, Jose. You just got here. This is a custom solver, pop sim, vellum. What's going on here? So what this is just a pyro simulation. So I did a smoke solver to get velocity, like movement or motion of smoke, and then I'm just in a SOP solver advecting or moving these lines using that velocity field, and resampling them every frame so that they kind of retain their resolution or their thickness and stuff like that. So that's all that's going on. So I'll let the simulation go back out, and I can do a quick jump through my network. It's a pretty quick, pretty simple steps. This is a little weird in some areas. I think we're getting that stuff we were having with the remesh, where like the stuff's folding in on each other. Just too many overlaps and stuff like that. So I think our turbulence settings and stuff like that might be a little bit too high. It is pretty cool seeing these, like, I don't know, tissues and stuff. So yeah, when it was shooting out so fast at the start, it reminded me of this kind of stuff. But could be a cool idea to actually, you could pump these velocities, like run the advection, but have it happening inside of a Vellum network. I don't know how easy it is to grow streamers and stuff like that with Vellum, but it could be a cool place to take this. So I think as well, when you move this resample too low, that's what can cause it to fold in on itself, where it's just trying to create like too much detail, kind of, if that makes sense. Any little minuscule like area of the velocity field gets messed up. What was that guy's name? I'll get to it in a second. I'll just do a quick rundown. So I'm doing a pyro simulation, just starting with a temperature and density, and then turbulence is kicking in to blow stuff around. I have this Taurus set up as a collision or like a shell object. So it's just a pretty simple, this is my source for the DOP network. And then this is this guy, and I have some buoyancy happening here. So that's what's causing like all of this stuff to rise to the top and then roll off. So sometimes you see it if you're boiling water or like lentils or something, you see the kind of convection motion like that. Those are the only two forces. And then this SOP solver, I'm getting the velocity field, like the motion from the DOP network. I'm starting with these little lines, and then just every frame resampling them. This stuff here is constraining them, like it's another additional collision pass, and this is the advect points to apply the motion of the smoke simulation. The washing machine pasta maker. So it's Vincent Schwenk. You just do Instagram.com/Vincent Schwenk, or I don't know what I don't think he has a direct link to his website or whatever. There's been good, was it up here? Whoops. Leaks my history. I've seen some different write-ups and stuff like him that's pretty nice. Do this. He's super talented. Really good eye for like creative ideas and stuff like that. The Microsoft Fluent video. Microsoft has been doing some pretty good work with their branding and advertisements recently. So I'm gonna crank the turbulence back a little bit, maybe just a scale of 0.5. I might try to reduce my division size a little bit just to see if we get some more detail. And let's try maybe a little bit bigger width, thicker ribbons, and a few more streamers. We'll start with something like that, maybe. But I think even with the information that we have right now, we might be able to get, like, you could already do some texturing of them at render time. Yeah, something with curve view and width you can do. You could kind of get like procedural or parametric UV attributes based on them. Or you're saying to even do something fancier with that. We have to be a little bit careful, I think, with some of that stuff, like, because I think it might be, like I was saying earlier, our root and tip, the curves might be getting reversed each frame because we're doing that resample. So like, if you're doing a ramp and changing stuff that way, it might get messed up a little bit. It'd be cool if they were all like little sheets of fabric or something like that. Little guys like that. So I don't know, my resample might be a little bit too high of a resolution still. One thing that I do sometimes is like be pretty conservative with that setting, so it's a low resolution resample. Just let this cook out a few frames. So my resample that happens every frame or during the solving is a pretty low resolution length, and then after the simulation you can do an additional resample at a super high pass. Usually do interpolating or subdivision, just depending on the detail you want to keep. And then this way you can kind of know that you won't be getting that. Do another simulation just to maybe show the difference. So because we're advecting stuff at a lower resolution, we'll kind of filter out that high frequency noise or those little like kinks and stuff like that during the during that process at least. So this, I guess we're just able to get more of a minimal kind of refined look, I guess. You fix like a bit of the ugly like penetrations or whatever, and get things just looking a little bit simplified. All right, I have another idea. Let's actually, I think we can just do this all with a single wrangle. We're just gonna use this cache a little bit more. So something, if you guys were, anyone was in here yesterday with that RBD stuff, we were looking at primitives. Under this intrinsic stuff, they have extra measured area. So this measured perimeter is actually pretty useful. What this is actually the length of the curve, the edge length. So we don't even need to use like a measure shop or anything to compute it. You can just use it directly. You might not even need to do, I'm gonna do it in a wrangle just because it's a little bit, you could do it with an expression here, but it gets a little bit ugly, like just modifying a long box of code. So what I'm thinking we can do is just manipulate or modify the thickness based on their length. So it's almost like balloons or something like that, filling up almost. I think we can do prim intrinsic to get, it's just a special function to access these attributes with the intrinsic attributes or whatever. Then just 0 to say from myself or my input, and measured perimeter. This is always such a long name, long thing to type. And then just the prim num. This is just the current prim num we want to get it from. Let's just try setting the color equal to that. We just go over to this other tab. It looks like it didn't work. Prim intrinsic. Yeah. Did I type that in wrong? I think it's like a spell. I don't think it needs to be, I don't think I need that colon. I'm gonna set this to primitives, just to figure out what's going on. Measured. Let's take a look at the, see what side effects has to say about this one. Prim intrinsic of X function. Geometry intrinsic name primitive number. I'm doing this properly. Let me just do a quick Google of this to see if I've spelled it wrong. Here's a guy, he's in the same situation I am. He's trying to access this prim intrinsic. Measure perimeter. Alright, I'm bailing on that. I tried to be fancy. I'm just gonna do it with a primitive. Do perimeter, and now we have it measured as a proper thing. I don't know what's going on with that. I'll just try to sort that out in my own time. I got owned. Tried to get fancy. So we could just grab it using prim now. This input, and what I can do here is just change this to length so it's a little bit more clear. And then we just need to tell it the primitive number again. So now we have the colors and brightness and stuff like that. We'll do L just for length. We'll type it all the way out. Now we can do width equals, I'll just do a fit function to remap this. So the source range will do maybe like 0.01. The source maximum, maybe 1 unit, 1 meter. And then the minimum length, we'll just do a super small number. And maximum or long width will be 0.05. So you can kind of see here, we have some smaller ones that are a little bit thinner. And then the bigger ones get kind of bigger, wider, like they're little balloons or something, like the long balloons the clowns blow. Just gonna increase that maximum so you get even longer ones there. And I think we're good. Might try this resample just a little bit lower, just to try to capture a little bit more detail from the velocity field. We'll just give it another flipbook. So I don't know, this guy was saying to maybe try Python codes. He's saying you can add in a group syntax. This guy, he always knows what he's talking about, Thomas. So this is all from 2015. I think it's before they added that primitive intrinsic vex function. But just research that stuff more. Get lost in the sauce in my own time. So this is a little bit more cool, I think. It's like some inflation kind of happening as well as yeah, no worries. Thanks for popping in a little bit. Yeah, so the VODs are a good resource for double making another pass, or I don't know. It's like if you take notes and read your notes or whatever, it sticks in your head a little bit more. So I don't know, it's a cool idea, kind of inflating these or blowing them up or whatever. But I'm thinking it was a little bit better when they were all like the same lengths. I don't know, they're just a little too big. So I'm just going to do a little bit of the inflation. But I'm just not gonna let them get like as big. So originally they were all 0.05. So we'll let the maximum be 0.05, but when they start out small, we'll try to have them be thin. So now we kind of just have that dynamic reveal happening, I guess. We might want more of that turbulence at the start. It's a little bit weird seeing the spin up. What we could also do is just delay our SOP solver, our post process. Like let the velocity of the smoke simulation happen unvisualized or without pushing the streamers into it. And then like give it 10 frames to spin up and then shoot these guys in. We'll just set that up real quickly. I usually do that just with a switch. Maybe we don't even need the switch, just the start frame right here. Just set the start frame to 8. And give ourselves another flipbook. So basically everything is still happening in terms of the pyro, the motion is the same, but we're just waiting a few frames to shoot the stuff into it. So it will change the end kind of result completely, because we're doing the resample and everything. Like it's kind of like the chaos theory or whatever. Any subtle change will pile up and everything else will be changed later on. So it's looking pretty cool. So this is just frame 68. I think there's still going to be a little bit more motion and stuff like that. We'll let this flipbook continue on a little bit longer. I'll just get some more water. I'll be right back. So it's pretty cool how the smoke cools down, which like causes the turbulence and the temperature, like all those forces in the smoke simulation are linked to the temperature. So as it cools down, our entire motion just kind of dissipates or de-accelerates. The party streamers. Could be a cool idea to like spell out some text this way or something, where you like fill each letter of type with these streamers. I'm going to hold off on other stuff for right now. Just go as another version. Sometimes it's nice to make a little movie of each version, like if you're doing iterations with somewhat different results, then you can just go through your like RnD folder and go through with QuickTime or whatever, the spacebar preview, and see what each result of the hip file is, like without having to open it, run a simulation, and spend like 10 minutes or whatever for each file. So I'm gonna try something maybe with no longer with these lines getting resampled. I'm gonna keep all this other stuff, just get rid of that, and then my source as well. I'm just going to do this add node and set it up to delete the lines and only keep the points. And then inside of here, I'm gonna do a merge. So basically this is saying source and combine the source with the geometry every frame. Maybe go back to setting everything to start on the first frame. And just increase this resolution. So just to work faster, we'll work at a lower resolution. Maybe I'll do disks. Then these things, try them a little bit smaller. Might be a little bit too small, too many of them. So let's try something here. It's going to be a little bit odd to have these like always emitting and shooting into the simulation. I just want them to kind of pop in once this motion gets more interesting and stuff like that. So we have our Taurus that we're using to like add hair to, or add lines to. What I can do with it is if I do volume from attribute, or attribute from volume, the other way around. I'm sorry. Let me just find it. Doing too many things at once here. Okay. So I don't want to do it to that because that was like my collision super special one. What I can do with this is use it to sample a certain attribute of the volume. I think if I do velocity, this might have to be split back into individual grids. I don't think so. I think it was just the first frame of the simulation, so there was no velocity. You can see it's working now. So we get velocity, we copy it onto the points. One thing I can do is the VDB analysis, and we can use it to find the length of the velocity. So now instead of having each direction as a separate color or component, we basically have a single black and white value that's the brightness or the speed of the velocity. So what I can do with this is use it to kind of find interesting areas of the simulation, or high moving, high speed areas, and maybe only scatter points on those areas. I'm just going to add another subdivide, maybe a couple iterations, just to get a higher resolution sampling of my velocity field. So more detail. Another thing you can do, instead of length, you have all these other operations that can be quite nice to use. So sometimes curl, this gives you, it takes a vector field and it gives you another vector field. So we're back to kind of getting different colors. But we can take that again and do a length. So instead of length of velocity, then we're doing length of curl of velocity. So this is kind of saying where is a lot of spin or like rotation happening in my velocity field. Sometimes you need to, with the length of the curl, it gets to be quite bright or quite intense. If I just remap it or underexpose my my viewport, then you can start to see this. So if we compare them, this is just length of velocity. Kind of looks like that. And then this is length of curl of velocity. So this is kind of measuring the spin of things. We might want to use it. I'll just try a blast. We'll delete by color. That cd.x. It's less than. These numbers are going to be quite high, so I could try maybe like 25 to start with. Maybe I have to set that to points, just to be sure. Yeah. So maybe 75, like a pretty high value. Then you could see these unconnected points are getting visualized as disks. So if I just do add, then I can do remove unused. So that just gets rid of any points that don't belong to a face or a polygon. Just try to keep this. My file is already a pretty big mess. Just keep plugging along. Usually my RnD scenes are like this the first time, and then once I actually find the result and like sit down to do the stuff properly, I'll try to lay it out and reorganize and just rebuild the stuff. And sometimes you can optimize things along the way. Like you're kind of rebuild it. You want to get the same result at first. You don't want to completely redo everything. But sometimes you can find optimizations or just like careless, slow things you were doing before. So now if I just do scatter, I don't want to scatter like a constant number of points, because even if it is just like one little polygon that's emitting, it's still gonna add 1,000 points to it. So instead of that, I can just do by density. So this one will look at the surface area, like the total area of polygons, and only add a certain amount of points based on that. So it should automatically increase and decrease the amount of points I'm adding based off of how many like visible polygons there are there. And then global seed, I usually, when I'm setting it up for this, I'll do random emission pattern or seed each frame. We should be pretty good. Give this one a try. So we don't see anything for a little bit, just because our curl field, our velocity threshold stuff that we were doing was below our certain condition or whatever. Then we aren't getting too many. So we could either increase the density scale, like points per area that we're generating, or we could decrease our threshold to try to create more particles. I might just do a little bit of both. Then I'm just going to turn on the template. Give this one a try. So if this was like a proper washing machine, this would almost be like a good process to add bubbles. It's somewhat similar to the way that the whitewater solvers and stuff like that in Houdini work. If you go inside of that, I think you'll see that they're messing around with that curl and then finding the length of the curl. Basically, you're finding like the turbidity of the fluid, like the just amount of mixing or rotation or spin or whatever that's happening, and then add like little air bubbles or particles or whatever to track around in the fluid that way. So I don't know what these could be. It could be just like little debris or dust or something like that. This is some real gold I'm giving you. It's like just pulling out the bag of tricks and just dropping a few gems. You've ever heard that people refer to them as gems? I think some of these old, I don't know if I have any, I have one here. Some of these old like graphics programming books and stuff like that, they call it gems, and I always thought that was funny. This one is a real, let me see if I can get this showing up right. So this is like a super weird landscape, and they just call it graphics gems version 5. There's actually like really useful information and programming and stuff inside of it, like super good tips or hacks or stuff like that. But I always just thought I was laughing at it that they called it gems, just like little valuable information. So Yeah, I don't know what this could be. It might be like little bits of dust, or you might want to shrink these out over time or something like that. 3D literature. Yeah, it's important to have a good, I don't know. Because I was like learning Houdini on my own, so I was always just finding the it's useful to pull whatever knowledge you can. There's less like documentation and tutorials and stuff like that for Houdini at the time as well, so it kind of forced me to it was just a different era, I guess, with 3D and all that stuff. It was a newer, harder to find that information. So there's some guys that are getting stuck at the side. We might want to change. We might want to change our. You're spoiled. Is this, you get lucky today? I don't know. Sometimes we get good results. Sometimes I try to do too much rigid body constraints and I get lost. So I'm just gonna reduce this peak, or increase it to basically I'm trying to stop these guys from staying still at the edges. So by making that peak distance bigger, we're basically increasing the padding that these guys are allowed to occupy. Now I'm gonna go up here and go back to a higher number with my masking. So there's less area that we're going to emit from, but then when we do create points, it's going to be a lot of them. So I think this might be a little bit more interesting because it's going to be like little jets, just a lot more like excitement or whatever. Instead of just like a constant thing that you could do with a slider, this is going to be like a big whooshes or something like that. So by doing that, we get some more like high density, low density areas and contrast and stuff like that. I think when I was going the other way, it was just gonna look a little bit flat. So I don't know, just add some more detail or stuff like that this way. It looks like we fixed that issue of stuff getting stuck in the velocity field. I'm gonna try something else. Just keep adding numbers to this. Make my P scale pretty small. And then I'm gonna subdivide another few more times. So what I'm trying to do is really keep some structure or definition with that additional subdivisions. So that when these patterns, when it finds these interesting areas of the velocity field, it will already have some contrast or like some definition to it. And then the scatter, just boosting that to really highlight or carve those areas into things. So I don't know, I mean, this could be little glints that get used with that ribbons or whatever kind of stuff that I was doing. That idea was kind of inspired by the Vincent Schwenk style stuff. You guys could also just get other ideas, or I don't know, once you start to understand the technical things, you kind of just have more tools at your disposal. So if you're doing like a magical spell or like a portal, this would be maybe a cool thing to add to like a portal opening. You just add these little energy spirits or wisps of energy or something like that. So I think we can do even more. We still haven't created too many of them. Let's do super big number. Then I'm also going to do another coloring. We'll just do bounding box again, so that the points, we get some color mixing kind of happening by attaching the color to the particles before we source them into our solver. Then I'm just gonna save this as a new version, just in case we crash or something terrible happens. I think I messed up the colors. Because I was using that color as a visualization. I messed it up. So this guy is operating with the color as well. I wanted to do the color before I was blasting faces, because this is going to change the bounding box. So one thing I can do, I think, is just do attribute transfer. So just after we create the particles, we'll just try to get the nearest color this way. All right. Should work this time. I promise. Yes. So this could be cool, maybe like color injection into your laundry. You're adding some dye or something like that. Spin cycle. There was this laundry machine commercial I got to work on a long time ago that was pretty fun. It was it's like Samsung Center Stage. So what they did was they actually Center Stage. What they did, they actually had these like LCD panels or whatever that had the products like 1-to-1 in terms of physical size versus the consumer or whoever's like viewing it. So it was just interesting to work at that like resolution. We were tiling, like paneling out cameras and renders and stuff like that. But they actually did that like spin cycle stuff. It's kind of, this stuff here reminded me of it a little bit. I was doing some of the water effects. There's like this bubble pop somewhere in it. I don't know if it's in this behind the scenes. Maybe in this one. It's like the thumbnail for this video. Oh, okay, here it is. Yes, I was doing some of this kind of stuff. Some of this stuff for sparkling water. So it's getting a lot slower with all these points. I don't know what we're up to. It might be could be 2 million, 20 million. Somewhere in that territory. I think there was like a designer that was working with us that was using Cinema 4D and Photoshop for like style frames and stuff like that. But then for the final shot, it was a traditional pipeline of like Houdini or flame artists that were doing the color correcting and compositing and stuff like that. Yeah, I think he was using Cinema 4D to lay out like those splines at the start as like a concept or a style frame. It was like the helix structure or whatever. So it might be a little too much like points and detail and stuff that we're scraping around with here. So I'm gonna decrease that a little bit. I'm gonna decrease this threshold as well. And maybe this time try the Pyro sim at a little bit higher of a resolution. Because these points, like we're visualizing them so small and everything like that, I'm just trying to pick up as much detail from, like you'll actually see the detail in the Pyro simulation with all of these structures and stuff like that start to form. But originally, I don't have the flipbooks of it, but when we were doing the pasta, the lines, we didn't care that much about resolution of the velocity field, like because it was more of a simplified, or I don't know, structure that we were, shapes that we were making or whatever. So we just were caring about like the broad motion of the Pyro simulation. But this time we really want to see some fine details, filaments. I don't know if that's the real word for it, but so what I've heard like visual effects supervisors and stuff say before. Fluid filaments. So side effect says the filament solver. That's I don't know. I've used it before. It's pretty cool, but I've never heard like vortex filaments. I don't know if that means like I think it's like the turbulence structures or something. The little things that rip off. Just tell me what the filament is. I don't care about all this other stuff. I don't know. I've always just used it to refer to like these little structures or I don't know, turbulence or whatever you see being formed. But yeah, this, I don't know, this could be more of like a powder, more of a magic spell or something like that. So it's still, usually when I'm doing this kind of sketching, like this is already a little bit slow to be working at this speed. It's maybe like I would say 5 seconds a frame, maybe. If you're just sketching and kind of playing around like this, you generally want to stay like 1 second a frame or under that even. Otherwise you're just kind of wasting time. If you have a render farm or simulation farm, you can get away with like batching out tests and jobs and stuff like that, but if you're just working on your own computer or whatever, you have to be a little bit more careful. So this is probably going to be the end, the last, we'll just let this keep going, just let the simulation keep going and see what happens. It's kind of cool getting a blur, it's like, it's just forming a blurry circle or whatever, but it's interesting at least the way that things are growing because we did the velocity curl threshold or whatever. So we'll probably wrap things up. If you guys have any questions, the delay, get them in. With the schedule and stuff like that coming up, I think I'm gonna leave Monday out of the schedule for a little bit, and just Wednesday will be the next stream. And then on this Streamlabs or Twitch, they've updated their UI and stuff like that, but I've tried to keep that schedule up to date, so we'll stay with this current time slot. The next one will just be Wednesday. All the gems, the Sunday gems. Yes, I don't know, maybe I'll just record some proper flipbooks or play less, or maybe even try some renders or whatever of this sometime later today or something. Jose, yeah, thanks for coming in for your first time. You got a session full of gems. It's a good time to come in instead of seeing me just hunched over a text box of Xcode and not producing anything interesting. So this stuff here is starting to look pretty cool. You like little mixtures, overlaps, or whatever of colors. It's starting to look kind of magical. Like you have some crystal, glass, orb, glass, I don't know, donut that's filling up with some spell. Yeah, I don't know. So getting some interesting colors forming from that mixing and stuff like that. All right, gonna end it. Enjoy the rest of your day. Thanks for everyone stopping by.